number of letters, then you're just going to put a space at the end to make it even, and then switch that up. So this matrix right here would be your message, and that was like the code that we had at the beginning. It would be very easy to break because the 20th letter is T, and the 8th letter is H, and the 5th letter is E, and it probably wouldn't take anybody very long to figure that out. For this, you will take your encryption matrix and you will multiply it by the message matrix. And let's just look at what has happened here. You guys can do this as well, or if you just want to watch. So that now means if we go back to the message that we're going to send, we would send 59, 16, 11, 20, 6, 49, 39, 50, 14, 21, 31, 26, 30, the next line, 79, 24, 16, 20, 9, 67, 54, 73, 14, 27, 43, 35, 35. Now, is this code going to be nearly as easy to crack? If you look at it, it's kind of crazy because, like, look at your spaces. This space is 20. This one's 14. This one's 24. This one's 9. Like, the letters don't even correspond, right, to this. The space has 4 different numbers right there. Here, you got 35 and 35, 2 completely different letters. They're not the same letter. So this would be much more difficult to crack. You know, your T here is a 20, your T here is a 59. So it, you know, doesn't correspond to its position in the alphabet. You're not getting the same numbers. You know, I probably could have put this up on the board, and y'all could have spent the whole class period trying to break it and never got it. If I had just put that up there. So this was a much better way of sending messages. Now, again, computers apparently can undo this very quickly, so it's a little antiquated, but I think it's kind of cool. So the thing is whenever you would send this message, so if I wrote down 59, 16, 11, 20, and I sent it to Isabella, she would need to know how to undo the code. Because as it is right now, she's not going to be able to figure it out unless she knows the decryption matrix for it. So whenever we multiply matrices, it's not the same as regular multiplication, right? A scalar multiple is, if we're just doing 2 times a matrix, we just multiply everything by 2. But we can't really divide matrices. So the inverse of multiplying 2 matrices together is not a division of matrices. What we have to do is we have to come up with the inverse matrix for this. So the way that we come up with the inverse matrix, in this part we're going to actually try to do. So the way we come up with the inverse matrix, this is your general code for an inverse matrix, and you will need this. You will put a star or something beside it. For our activity tomorrow, you'll definitely need it a lot. And you can use all of this. It's all open note. You can use anything that you need as far as that goes. So if I have the matrix A, B, C, D, to find the inverse matrix, and they're using that to the -1 to indicate that that's the inverse matrix, I will do 1 over A times D minus B times C. And I believe that's called the determinant of the matrix, but I'd have to go back to some linear algebra to remember for sure on that. So you'll do A times D minus B times C. So whatever's in the A position times the D position minus B position times C position. And then you're going to multiply that by the rearranged matrix. So A and D switch places here, and then B and C stay where they're at, but they change signs. Okay? So let's get the inverse matrix for this one. So if we're doing the inverse matrix, E is 2, 1, 3, 1. So E inverse is going to be 1 over 2 times 1 minus 1 times 3. There, so we're doing A times D minus B times C. And we're going to multiply that by D. A and D have to switch, so I'll put a 1 here and a 2 here. And then 3 and 1 stay where they're at, but they're going to change signs. So we'll have a negative 1 here and a negative 3 here. Everybody good there? Okay, so then that would be 2 times 1 would give us 2, 1 times 3 is 3. 2 minus 3 give us negative 1, so we've got 1 over negative 1 times 1, negative 1, negative 3, 2. And you would multiply those together. It's just going to change the sign of everything, and you get negative 1, positive 1, positive 3, negative 2 for that. Alright, so that is our decryption matrix, if you want to call it that. Here is our inverse of our encryption matrix. So, if well, I'm just going to we'll practice this on the next one where we're actually doing it. So if I multiply this matrix by this matrix of 59, 16, 11, 20, and so on, it'll get me back to the 28503. So I can do that there. So let's try one. Okay, so math is fun is our first message that we're going to try to send, and that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we've got 11 letters. We're going to have to go up to 12 so we have an even number, and we're going to do a 2 by 6 matrix for that. So 1, 2, 3, 4, 5, 6. And we're just going to use our alphabet code for this first part. So I know I copied this front and back, and now you can't look at your code, so you just copy mine if you want. M is 13, A is 1, T is 20, H is 8. We'll put a 0 for the space. I is 9. And then go to the next line because we ran out of room. So S is 19. Another 0 for a space. And then we've got F is 6. U is 21. N is 14. And I'll put a 0 on the end there. Okay, everybody good there? We're going to enter this into the calculator. So you're going to go second matrix on your calculator, and make sure you go over to edit. And I'm just going to put this in as A right here, and I think I still have it in from okay. And then once you have that matrix in, you also want to put your encryption matrix in. You can enter it as B. So if we go back to the matrix sheet here and go down to B, you want to enter that encryption matrix there. So if we want to code this message, all we've got to do is B times A for this. B's got to go first because we can't do A times B for this because the dimensions wouldn't be right. So we're going to do, go back to the main screen, and then we'll do matrix. And don't go over to edit this time. Just go down here and do B times matrix A. Okay, so everybody check on your neighbors. I know some of your neighbors are missing. Make sure you can get that. Make sure you got that 7 there. Or you did that. Yours is right. You're right. Perfect. Great. Okay. So, what we also need to make sure we can do, because what you'll be doing in your activity tomorrow, and I'll explain it at the end of class in more detail, but you will need to be sending messages to people in your group, secret messages. And so you will encode the message and you'll send it to them. When they get it, they've got to decode it so they know what it says, right? So, like our coded message, let's write it down here real quick. I guess I could have written it. I got 7, 2, 34, negative 5, negative 14, and 18. And then 42. So you could send that message, and it would be secret. Nobody could know what it says. And then they would need to be able to decode it, because whenever they get that, it's going to be nonsense, right? They're not going to be able to know what you mean whenever they just get this. So we need to make sure that we can decode here. So one trick here for this, first of all, a couple things. If you have done anything, like if you hit enter again or something, and you did this, like, or you typed in a 5, it may not let you, like, it's not going to let you scroll over after that. Like if you're wanting to see the rest of that matrix and it won't let you see it, because I had a lot of people run into that. If you run into that, if you press second and enter, it brings up the last thing you typed in. And then you can just hit, oh, don't hit the 5. Then you can just hit enter, and now you can scroll again. If you do anything after you do the matrix, it won't let you scroll though. So that's just a little note. You also can store this matrix so that you don't have to type it in manually for that. So for what we want to do, we need to store this matrix. So it should be the last thing that's in. Right above the on key right here is a button that says STO and has an arrow. We've used it for storing variables before, but you can also use it for matrices, so you don't have to type this whole thing in. All right, so you're going to hit that. It should say answer and put an arrow. And then you want to store it as a matrix. I put mine as C. I would not do A or B, just in case you need it for anything later. You could replace it, but I'm going to store it as C. And then when you go back to the matrix menu now, you should see it should have a 2x6. Oh, gracious, what am I doing? Listen up. Go back to the matrix menu, you should have a 2x6 by that C. Right there, so that is stored. Okay, everybody got theirs stored?
How do you store it?
It's right here above the on button, STO. See it, and then you're going to just go back to the matrix menu and store it as whatever letter you want to store it as. I put it as C. So we need a decryption matrix for this to see if we can get back to what we had. So that is where we have to use that formula that we just had before. So it's going to be 1, let me draw, 1 over, we do A times D, so that's 2 times 3, minus negative 1 times 1, And then we're going to multiply it by, in this matrix, we're going to switch the 2 and the 3. So that puts the 3 here and the 2 here. And then the 1s stay where they're at, but their signs are going to change. It actually makes it look like they switched places on this one, but that's not what was happening. Their signs were changing. So this is going to be 1 over 6 minus -1, and the minus -1 will become like a plus, so we'll get 1/7 right there, times 3, -1, 1, 2. In cases like this where you get something like 1/7, I would just stick with fractions. It's going to be easier to deal with. So if you multiply everything by 1/7, you're going to get 3/7, 1/7, -1/7, and 2/7. So that would be our decryption matrix. That is our matrix we're going to use to undo the code. Everybody good there? Okay, so let's check to make sure it worked. So what we need to do to decrypt the matrix is we need to take matrix D and multiply it by matrix C, right? The matrix, our decryption matrix multiplied by the coded message. So we're going to first need to put matrix D in. So I'm going to go down here and put this in D. I think I already did. But when you type in 3/7, you'll just do 3 divided by 7. And when you hit enter, it'll change it to a decimal for you. And then you'll type in the others. So you'll get that matrix there. And then, just quick, go back to the main screen. And you want to do matrix D times matrix C. And hopefully it's going to give us what we started with, 132809. Yeah. Yeah. So, and now you're back to what you started with. Okay, this is a long one.
Can we just do the GTD thing?
Let's do it to see if we can do it, because this is about, you will have some messages that are, this would probably be like the longest message that you might get tomorrow. But let's do it to see if you can do it. I'll help you with this is, since I've already done it in the second period, it needs to be a 2 by 18 matrix. So and so we're just going to use the letter code first. So I'll put it up here. You guys check to see if you're getting the same thing. I did the same thing. Bucking does not have a G. It's much too formal. So, this is what we should have for our message matrix. So what I want you guys to do, and I want you to try it on your own without me. I'm going to do it up here, and then we'll look at it. I want you to encrypt the matrix, write down the coded matrix, and then I want you to try to reverse that. So try to find the decryption matrix and see if you can get it to go back to what it was. And you can work with your partner to kind of check and make sure that you guys are both doing it right. And I'm going to freeze my screen so you can still see that, but I am going to do this up here. And that is 18 spots, so it's a 2 by 18 when you start typing it in. Gosh, I've written too big. Yeah, yeah, yeah. I've got to. I'm gonna have to continue it down here whenever I show you guys what I've got. It's gonna look bad. I thought I was writing small. A lot of numbers. Oh gosh. Messed it up. Oh, see what I did.